Welcome to Pure Physics. Today we are going to see Chapter 1, Nature of Physical World and Measurement of Class 11th, Tamil Nadu Board. Today's topic is topic number 1.4, Measurement. This is in page number 7 to 11 of the textbook. And the subtopic of this video is Physical Quantity. What is physical quantity? Anything in physics that can be measured is called as physical quantity. In other words, physics does not exist if we don't measure anything. And the exact definition of the textbook is nothing but quantities that can be measured and in terms of which laws of physics are described is called as physical quantities. We have two sentences here to understand the concept. One is quantities that can be measured. For example, if we need to find the length of a rope, or we need to find the weight of the rice bag, or we need to find the cover containing salt. If we want to find the weight of the cover containing salt, we need to use certain application in order to find the weight or in order to find the length. And another sentence, which is nothing but laws of physics are described. Using physical quantities, you will describe laws. For example, if we take the Newton's second law, which is nothing but F is equal to m into A. F is nothing but force. F is nothing but force. M is nothing but mass. And A is nothing but acceleration, right? So these three are physical quantities. So I'm going to combine these two physical quantities in order to bring a new physical quantities. So and this has been created as a law. It is nothing but Newton's second law. So this example is the explanation of this sentence in terms of which laws of physics are described. So using the physical quantities, we are stating the laws of physics. So that is the meaning of the second sentence. So again I'm going to repeat this. Quantities that can be measured and in terms of which laws of physics are described are called as physical quantities. For example, length, mass, time, force, etc. are called as physical quantities. So till now we have been clear about what is physical quantity. Let us move on to the next topic, which is the different types of physical quantity. The different types of physical quantities is nothing but fundamental quantities and derived quantities, which is of two types. Fundamental quantities are the quantities that cannot be expressed in terms of any other physical quantity, which is nothing but there are 7 quantities that has been given in our books. One is the first one is length. Can you express length in terms of any other physical quantities? No. The same goes for mass. Can we express? No. The third one is time. The fourth one is amount of substance. The fifth one is luminous intensity. The sixth one is temperature. The seventh one is electric current. So these are the 7 fundamental quantities that have been listed in our book, and there are 7 different definitions for these 7 fundamental quantities. We will see in the upcoming videos. So these are called as fundamental quantities, and you cannot express these 7 quantities in terms of any other physical quantities. So that is why they have called as fundamental quantities or base quantities. So now in the other type, which is derived quantities, it is the opposite. So derived quantities are the quantities that can be expressed in terms of any other physical quantities. For example, if you take force, again I'm going to take Newton's second law of motion, F is equal to m into A. I'm going to use these two physical quantities in order to bring a new quantity, which is called as I'm going to get that force in terms of m into A. So when I multiply m into A, which is mass into acceleration, I'm getting a new quantity called as force. That is called as derived quantity. So there are 25 derived quantities that have been given in our textbook, and they have been given the formula for those quantities, and the units for that. We will see in the upcoming videos. Let us move on to the next topic called as units. So what are units? Units are nothing but they are fixed standard of quantities chosen by a group of people in order to prevent the confusion whenever a quantity is being measured. So the definition goes like this: an arbitrarily chosen standard of measurement of quantities that has been accepted internationally is called as unit. What is this arbitrarily? Arbitrarily means people mutually understood and agreed that there should be the units in which the confusion of measuring the quantities does not arise. So for example, if people doesn't use units and they have been asked to measure the length of a table, for example, if we say 5 meter, and if there were no units, they would call 5 long table. So if they use 5 long, do we understand what is that? No. So in order to prevent those confusion, people agreed to have a unit so that everyone could understand what is the meaning of that 5 meter. 5 meter long table means the length of the table is 5 meter. So that is why a group of people agreed that there should be unit which has to be accepted internationally. So that is why an arbitrarily chosen standard of measurement of quantities that has been accepted internationally is called as unit. For example, the unit of length is meter, and the unit of mass is kilogram, and the unit of time is second. So there are many units for many quantities. So these are the three examples that I could give you right now. And there are different types of units. In the previous topic, we studied about the different types of physical quantities, and now we are going to learn the different types of units. So there are again two different types of units, which is nothing but fundamental units and derived units. So fundamental units are nothing but the units assigned for the fundamental quantities are called as fundamental units. And the derived units are nothing but the units obtained by the operation of multiplication or division of the units of the fundamental quantities are called as derived units. For example, if we need to, again I'll take the same example since it is easy to understand. I'm going to take the same example, which is nothing but the Newton's second law of motion. F is equal to m into a. What is the unit of mass? Kilogram. What is the unit of acceleration? Meter per second square. So when I multiply this, what would I get? Kilogram meter per second square. Or we have a standard unit for force, which is Newton. Okay. So you are performing certain operation so that you are deriving a final unit for the given derived quantity. So the unit used for derived quantities are called as derived units. So there are two different types of units, which is again fundamental units and derived units. So let us move on to the next topic, which is system of measurement. There are different types of system of measurement, namely three types, which is nothing but FPS, CGS, and MKS. So what is this FPS? FPS is nothing but foot pound system, pound second system, foot pound second system. CGS is nothing but centimeter gram second system. MKS is nothing but meter kilogram second system. So we have two different names for each, for the first and the second system. For the first FPS system, the name is British Engineering System. And for the second one, which is CGS system, the name is Gaussian system. So the most common system that is being used in this world is MKS system. CG system and MK system are part of metric system, while FPS is not a part of metric system. In our textbook, we will be mostly dealing with MK system, and in most part of the numericals, we will be seeing the CGS system.